Alright, so today we will be solving logarithmic equations, which we started a little bit of yesterday when we were looking at our natural logs. So it's going to be the same way. And so the first thing we want to do is make sure that our logs are condensed. We don't want them to be expanded. We want them to be as condensed as possible. And then we're going to use that one-to-one property that I talked about. If the log and the base match, then m equals n. So then we'll set those equal to each other and solve, and then we got to make sure that we don't have any extraneous solutions. So the first one we're going to do obviously is number 1. And so on number 1, first thing we want to do is condense if we can. I don't have anything to condense. Then we'll check that the bases match. They do. So we'll say 5x plus 9 would then have to equal 6x. So then I'm going to solve for x, and I get 9 equals x. And then we've got to plug those back in, make sure we don't have extraneous solutions. So log base 5 of 5 times 9, 45, plus 9 equals log base 5 of 6 times 9, which is 54. And 45 plus 9 is in fact 54. So we've got matching sides. So our solution is that x equals 9. Then on number 3, we're going to check that we don't have to condense anything, which I don't see anything that we would need to condense. Then we would check that the bases are the same, and they are. So we'll set the other part equal to each other and solve for that variable. So we get that w is 6. So log base 9 of 6 minus 3 times 6 equals log base 9 of negative 2 times 6. 6 minus 18 is negative 12. And negative 12. Now here we do have that both sides equal each other, but we can't take logs of negative numbers. So if you ever plug it back in your variable and get that you're taking the log of a negative number, then it is extraneous. Which means we have no solution. Now number 5, we're going to make sure that we don't have anything to condense first, and then we will start to solve. So I see this 3 here that we're going to move into the power. So log base 7, 4 to the 3rd power equals log base 7, 4a minus 8. And their bases are the same, so I'm going to set 4 to the 3rd equal to 4a minus 8. 4 to the 3rd is 64. So 64 equals 4a minus 8. We'll add 8 to 64. 72 equals 4a. And then we'll divide by 4. And we get that 18 is our value for a. So we'll plug it back into the original. 3 log 7,4 equals log base 7 of 4 times 18 minus 8. So move that power to the 4, so it's 4 cubed, which is 64. And 4 times 18 is 72. So we've got log base 7 of 72 minus 8. And 72 minus 8 is 64. They match, they're non-negative. So A equals 18. Number 7, we're going to do the same thing. We're going to make sure we move any powers, condense if we have to. So this becomes the power on 25. Log base 6 of the square root of 25 equals log base 6 of 23 minus 4w. Log base 6 of 5 equals log base 6 of 23 minus 4w. So 5 would have to equal 23 minus 4w. We'll subtract 23. Should be negative 18. Yep. And divide by negative 4. And we get 4.5. And then we'll plug that back in, make sure that it works. So we've got log 6, 5 equals log 6, 23 minus 4 times 4.5. And 23 minus 4 times 4.5 is 5. So log base 6 of 5 does equal log base 6 of 5. They equal non-negative. So 4.5 is W. On this one, we see that they are already condensed, and we have the bases the same of 4. So m squared equals 18 minus 7m. Whenever we end up with a square in the equation that we're solving, we want to move everything to the same side. So m squared plus 7m minus 18 equals 0. So when I moved them over to the other side of the equal sign, I changed their signs. Then I'll factor. Two numbers that multiply to negative 18 but add to 7 are positive 9 and negative 2. So m would equal negative 9 and positive 2. So now I have to test that both of those work. So I'm going to test negative 9 first. That would be log base 4 of 81 equals log base 4. Let's see, negative 9 times 7. 18 minus negative 63 is 81. Then we'll check when m equals 2. Log base 4 of 2 squared, which is 4. Log base 4 of 18 minus 7 times 2, which is 4. Both work. They give me non-negative logs, so both of them are answer. So we can have negatives, but this cannot be negative. So the variable itself can be negative, but once you plug it back in, it cannot give you a negative. Now the other type of solving with our logarithms is when we have the log equals a number. So we can't compare two sides when there's only one log to work with. So when that happens, we'll convert it to exponential form and then solve. So on this one, we've got log base 2 x minus 4 equals 6. I'm going to convert it. So we have 2 to the power of 6 equals x minus 4. 2 to the power of 6, I think it's 64 Yeah. So 64 equals x minus 4. Add 4. And 68 is our value for x. And we have to plug that back in, make sure it's non-negative. So log base 2 of 68 minus 4 equals 6. Log base 2 of 64 equals 6, which if we convert it, we get 2 to the 6 equals 64, which is a true statement. So 68 is our value for x. Now on number 13, it looks like we've got 2 logs to work with, but we're going to have to condense them into a single log. So we're going to have log of 2x times x minus 5 equals 2, which is log of 2x squared minus 10x equals 2. So whenever we don't see the base, it is a 10. That's going to be my first, last, middle. So you've got 10 squared equals 2x squared minus 10x. That's 100 equals 2x squared minus 10x. I have a square, so I'm going to move everything to the same side as the square. Change its sign if it's moving sides. So 2x squared minus 10x minus 100 equals 0. And I know they can all be divided by 2, so before I factor, I'll do that. Get x squared minus 5x minus 50 equals 0. And then I'll factor. We get 2 on the outside, x. We need two numbers that multiply to negative 50 but add to negative 5, which would be negative 10 and positive 5, which means x is equal to positive 10 and negative 5. So then we'll plug that back in and check. Log of 2 times 10 is 20 equals, log of 10 minus 5, which is 5, would equal 2. Condense them, multiply them together. 20 times 5 is 100 equals 2. Base of 10 will convert. 10 to the power of 2 equals 100 is true. Now let's check when negative 5 is what we're working with. So log of 2 times negative 5 is negative 10. Can't use it. So my answer is only x equals 10. And then on number 15, we're going to condense first. So log base 6, they both have the same base. So when I'm adding, I'm going to multiply them. So log base 6 of x squared plus 9x equals 2. First, last, and middle. 6 squared equals x squared plus 9x, which is 36 equals x squared plus 9x. And then I'll move everything to the same side. So I'm going to move that 36 over, make it negative. Now I need two numbers that multiply to negative 36 but add to positive 9. Positive 12, no. Yeah, positive 12 and negative 3. So then x would equal negative 12 and positive 3. And then we'll check them both. So first we'll check negative 12, log base 6, negative 12 plus 9. That's negative. It's negative 3, which means we can't use that one. log base 6 of 3 plus 9, which is 12, plus log base 6 of 3 equals 2. Log base 6, multiply them, 36 equals 2. Convert 6 to the power of 2 equals 36. That's true. So my answer is x equals positive 3. So this was solving with our logs. We did see some of it yesterday again with our natural logs. So for your homework, you'll be doing the ones highlighted in yellow, the evens, the right side of the worksheet on both sides, and then just make sure that you turn it in on Canvas to get credit for today's work.